Hey, today we are going to talk about position, velocity, and acceleration. Position is the name that we give to the original function, f of x. So the position is the original function, tells you where you are. The velocity, the speed, velocity is a rate of change, distance over time. So that is our first derivative. That is f prime of x. All right, that is the first derivative. All right, and if we change our speed, rate of change of speed, rate of change of velocity, that is our acceleration. So that is our second derivative. And we notate that by f double prime of x. All right, or the Leibniz notation is d squared y over dx squared. That's the Leibniz notation. All right, so again, position refers to the original function, f of x. Velocity is our first derivative. Remember, a derivative is a rate of change. Velocity is a rate of change in distance over time. So velocity is the real world name that we give to the first derivative, f prime of x. And then, let's review the notation. The Leibniz notation is dy dx. All right? And then the second derivative is acceleration, the rate of change of velocity. If we change our speed, that's acceleration. So that's the second derivative, f double prime of x, or the Leibniz notation is d squared y dx squared. All right, let's talk about the difference between distance and displacement. We know that distance tells us how far an object is from a reference point. It has nothing to do with direction. So distance is simply how far. All right, but displacement tells how far an object is from a reference point. It tells how far an object is from a reference point and in what direction. All right, so this is not only how far, it also tells you what direction you are going in. So how far and in what direction. All right, so we need to know the difference between distance and displacement. We also need to know the difference between speed and velocity. All right, so we know that speed tells us how fast we are going. So speed is how fast. It has nothing to do with direction. But velocity tells us not only how fast we are going, but it also tells us what direction. So velocity tells how fast an object moves and in what direction. All right, so make sure we know the difference between speed and velocity. Okay, so let's look at example number 1. A football is punted. It's displacement. Now, displacement is another name for position. All right, displacement. It tells us where we are. That all refers to the original function. All right, we've got to know our functions. So, displacement is another name for position. These are both names for the original function. So here's our function for our punted football. It's a negative t squared, so that's an upside down parabola, which would make sense for the path of a punted football. It is going to go up and then come down. So this is our original function. We want to find the velocity. The velocity, again, is the first derivative. All right? So the only derivative rule we know right now is the power rule, and luckily it works. These are polynomial terms. So that is just the power rule. So to find y prime, we take the power rule. So we have the derivative of negative 16t squared. 2 times negative 16 is negative 32. T to the first. The derivative of 36t, this is a 1 right here. So the 1 times the 36 gives us plus 36 t to the 0, but we know anything to the 0 power is equal to 1, so we don't really need that t to the 0. And we know the derivative of 3 is 0. So our velocity function is negative 32t plus 36. All right? So now we want to find the velocity at 1. So we just plug 1 into the velocity function. It looks like this. We want y prime of 1. All right, so that gives us negative 32 times 1 plus 36. All right, so negative 32 plus 36 gives us 4. Okay, now in calculus, we always want to do units. So let's look over here in units. Our y value is in feet. Our time, our x value, is in seconds. All right, so for a derivative, here's how we do units. Because derivative is change in y over change in x, we put the y units on top, and we put our x units on the bottom. The units for a derivative will always be in a fraction. All right, so this is going to be 4 feet per second. You have to do units. Okay, now let's find the velocity at 2. So we want y prime of 2. So we plug 2 into our derivative function. So negative 32 times 2 for t plus 36. So negative 32 times 2 is going to give us negative 64 plus 36. It's going to give us a negative velocity. So negative 28, and it is feet per second. The y units on top, the x units on the bottom. Okay, now let's talk about this. This is important. Instantaneous rate of change. That is a fancy name for derivative. All right, sometimes people will talk about the derivative as this: IROC, I, instantaneous, R, rate, O, of change. IROC is the derivative. So when you change your velocity, you change your speed, that is the acceleration. We kind of talked about that earlier. Acceleration. All right, so the acceleration is the second derivative. It's the derivative of the velocity. Alrighty? So we're going to find the football's acceleration. So we just take the derivative of the velocity right here. So y double prime, we just use the power rule. The derivative of negative 32t to the first is negative 32t to the 0, which is negative 32. So we know that our acceleration is constant. All right? Example number 2. Now our displacement, which again is the original function, is given by this function. It's a cubic. All right, our time is in hours, so that's our x-axis. Our y is in miles, that is our y-axis. So the first thing we're going to do is we're going to find the velocity. So we take the derivative of the displacement, the original function. So the derivative of 3t cubed using the power rule is 9t squared. All right, the derivative of negative 30t squared is negative 60t to the first. The derivative of 64t is just plus 64, and the derivative of 57 is 0. So this is our first derivative, our velocity function. All right, now we plug in 2. So if we plug in 2, now the easiest way to do this is go to your table. All right, put this in y equals in your calculator, and then use your table to find this. It's much easier. All right, so do that right now. Pause the video and find these values. Okay, check your work. At 2, the velocity was negative 20 miles per hour. At 4, the velocity was negative 32 miles per hour. And at 6, the velocity was 28 miles per hour. All right, so now we're going to find the acceleration. The acceleration, again, is the second derivative. All right, you just take the derivative of the velocity. All right, so y double prime, the derivative of 9t squared using the power rule is 18t to the first. The derivative of negative 60t is negative 60, t to the 0, which is 1, and the derivative of 64 is 0. So this is my acceleration. This is my second derivative. Remember, to find the acceleration, you take the derivative of the velocity. Okay, now put this into y equals in your calculator, and then right here, go into your table to find these values. Go ahead and do that right now. Pause the video and come back and check your work. Okay, check your work. You should have negative 24 for 2, 12 for 4, and 48 for 6. Now, let's figure out how do we do units for the second derivative. Okay, so we need to do units for the second derivative. All right, so acceleration, we know is the change in velocity over time. All right, so our velocity is in miles per hour, and our time is in hours. So we always put the y units on top, and we put the x-axis units on the bottom. Now we never want to leave a fraction in a fraction, so we need to simplify this. The easiest thing to do is make the bottom a fraction, h over 1. All right? Now, to divide by a fraction, we remember that we multiply by the reciprocal. So we're going to keep this fraction the same, miles over hour. We're going to change it to multiplication, and we are going to flip the bottom fraction, 1 over h. All right, so again, to divide by a fraction, you multiply by the reciprocal. Now we just multiply tops and bottoms. On top, we get miles, and on the bottom, we get hours squared. So it's miles per hour squared. That is how you do units for a second derivative. So let's go ahead and put those in. 24 miles per hour squared, 12 miles per hour squared at 4, and 48 miles per hour squared. Okay? This box right here tells us how to figure out if you are speeding up and slowing down. So, if your velocity and acceleration are the same sign, you are speeding up. So same sign would be a positive and a positive, or a negative and a negative. All right? If the velocity and acceleration are opposite signs, then you are slowing down. So that means having a positive velocity and a negative acceleration, or having a negative velocity and a positive acceleration. So we are going to take the values for the velocity and the values for the acceleration, and we're going to figure out if we're speeding up or slowing down at each of these times. So at 2, my velocity is negative, right up here, a negative 20, and my acceleration is negative. So I'm going to put that right here. All right, so they are both negative. That means that we are speeding up. The signs of our velocity and our acceleration are the same. All right, at 4, let's look up here. At 4, our velocity is negative, and our acceleration is positive 12. So our signs are opposite, a negative velocity and a positive acceleration. If our signs are opposite, we are slowing down. And finally, at 6 hours, up here, at 6, our velocity is positive, and at 6, our acceleration is positive. So our signs are the same, positive and positive. So at 6, we are speeding up. So we have to remember, if we are trying to figure out, not speeding down, hello, we are speeding up. Okay, so just remember, if you're asked if you're speeding up or slowing down, you look at both functions, the velocity and the acceleration. Okay, right now I want you to pause this video, and I want you to do this on your own. You're given the position function. Remember, the position function is the original function, f of x. All right, the two names for the original function, let's just get this down, is position. It is also called the displacement. It just tells us where we are. All right, the first derivative, f prime of x, the fancy name for that out in the real world is the velocity. All right, and then before we finish, f double prime of x, that is the second derivative. All right, And the real world name for that, when we change our velocity, when we change our speed, is acceleration. So we need to know those three functions. So up here on your own example, I want you to pause the video and I want you to go through and try this. All right, here's the original function. Find the velocity, the first derivative. Find the acceleration, the second derivative. Plug these values into the velocity here and into the acceleration here. Okay, hopefully you tried this on your own, but let's go through it. The derivative of 1/3 t cubed is 1t squared. The derivative of 2t squared is 4t. The derivative of 3t is 3, and the derivative of 1 is 0. Now when we go and find the second derivative, the acceleration, the derivative of t squared is 2t to the first. The derivative of negative 4t is negative 4, and the derivative of 3 is 0. So remember, the degree goes down by 1. Our original function is a cubic. Our first derivative, velocity, is a quadratic, degree 2. And our second derivative, the acceleration, is linear, t to the first. All right, so now we are going to plug both of these functions into our calculator. Okay, so I would put this in y1 into your calculator, and I would put this into y2. Use your calculator. Okay, it looks like this, you guys. Here's our table. Here is our velocity right here, and here's our acceleration. We started our table at 0.5 right here. These are 1 unit apart, so I put my increments in 1. And here are my velocity values, and here is my acceleration. All right, so at 0.5, this is the velocity, and this is the acceleration. So positive 1.25 and negative 3. All right, we can say that x at 0.5 is increasing, all right, because our velocity is positive. All right, so this is increasing. All right, that's, all right, our velocity is positive. Remember, if your derivative is positive, your function is increasing. All right, are we speeding up or slowing down? We have a positive and a negative. So when you have opposite signs, you are slowing down. Okay, let's go to 1.5. At 1.5, you guys, the velocity is negative 0.75 and the acceleration is negative 1. So we put those in right here. Negative 0.75 and negative 1. All right, now here, our velocity, our derivative is negative. So that means we are decreasing. All right, so we are decreasing here because our velocity is negative. Remember, if your function is decreasing, the derivative is negative. All right, let's look at our signs. We are negative and negative. We have opposite signs here. We have a negative and a negative opposite sign. That means we are speeding up. All right, and finally, let's look at 2.5. At 2.5, our velocity is negative 0.75 and our acceleration is positive 1. So negative 0.75 and positive 1. All right, are we increasing or decreasing? We are looking at the derivative right here. We are negative here, so we are decreasing. All right. Our velocity, our first derivative, is negative. All right, so again, right here, I'm going to underline it and review. Increasing or decreasing, you only look at the velocity. All right, the first derivative. Okay, and the rate is just that value. Okay, and then finally, we have a negative and a positive. So opposite signs means we are slowing down. A negative and a positive, opposite signs, we are slowing down. All right, calculus, this video was long enough, but go through this and we will keep in touch.